ensure larger devices such as laptops are stowed at this time in a bag under the seat.
Good morning.
Good morning.
Jana?
Yeah, I'm Jana. Oh, thank you. I'm going to Lynchburg.
Lynchburg, yeah. To play pool at a bar called Mud Puppies years and years ago.
Hi, I'm Gordon Rankin. I'm the designer of Dragonfly for AudioQuest, and we do all the manufacturing at Mirac Inc. in Lynchburg, Ohio, just east of Cincinnati.
This is your smock to put on, so you can go onto the floor, and that way it'll take the static out of your body before you touch the boards, and also have your badge, and put your badge on the chest. That way they know that you are a visitor for our site.
Thank you.
All right, thank you.
Hello, my name is Jim Goble and I'm the manufacturing engineer here at Mirac. Today we're going to look at how we build the AudioQuest DragonFly Cobalt, but we use the same processes when we're building the reds and the blacks. I've worked with Gordon since day one, AudioQuest, to get these processes set up and to help develop their product. We'll start the process with how we receive the materials to build the DragonFly Cobalts. We barcode, track, scan, ensure we have all the materials necessary to build the product. After receiving the materials, they're placed in our stock room. Here they're held until we need to pull the kit, which is all the components needed to assemble the product, out to the production lines. We use the VJ Electronics X-ray machine to count our inventory. This will count every component on each reel and give us exact counts of everything we have in stock. Once the parts are delivered to the surface mount line, we can begin production. First, the components are loaded onto the feeders for the placement equipment. At this point, we can set up the line and load the bare boards onto the bare board loader. The bare board itself actually consists of 10 of the DragonFly Cobalt circuits. So instead of processing one at a time, we're actually processing 10 just for efficiency and throughput. The bare board loader is stacked full of the bare boards, and then it will drop each bare board onto the line for production. The next process is to apply paste to the circuit board. The solder paste is a mix of fluxes used to clean the circuit board, a mix of the metals that actually form the solder joint itself. And we use a stencil, which is a metal foil with openings in it, to apply the paste to the specific parts of the circuit board where we want a solder joint to be formed. This will allow the components to be attached and give electrical continuity through the components onto the circuit board. The next step in the process is the board goes through the solder paste inspection system. What this does is look at every deposit of solder paste we just placed on the circuit board and make sure that the previous process was done correctly. This looks at the location of the solder paste as well as the true volume of the solder paste to ensure there's enough there to ensure proper function. So after we ensure the paste is properly placed on the circuit board, they go into our placement machines. These are amazing machines that can do the work of several people in a short amount of time. The machines themselves are placing about 32,000 components an hour, and they do it with a very, very thousandths of an inch high accuracy placement. This ensures that the components will work and function properly and are soldered properly through the next processes. On the DragonFly Cobalt, there's actually 58 different parts placements. So for a panel, we're doing 580 placements, and we can do that in just over a minute with those pieces of equipment. Very fast, very accurate. So once the board comes out of component placement, it goes to a manual process, and this is where we're applying the USB connector onto the circuit board. The circuit board is placed into a jig. The jig is to hold the panel and to hold the USB connector straight so that everything aligns in the case properly afterwards. Once these are placed into that jig, then they can be placed into the reflow oven. The reflow oven is what heats up the component and the circuits, and the solder paste that's on the circuit board creates a liquidous molten state so that the parts can be attached to the circuit board. Basically, we're heating the paste and sticking the components to the circuit board. So inside the reflow oven, the process is taking the board and the components and the paste to actually about 245 degrees C or 475 degrees F. That is the point at which the solder will properly flow to the components in the circuit board. Once the circuit board comes out of the reflow oven, that side is finished processing. The DragonFly Cobalt is a double-sided circuit board. So now we have to run the whole system back through the whole process again. So we're going to do paste print, placement, reflow again on this second side to finish populating the circuit board. Once the circuit board emerges from the reflow oven the second time, we now actually have a completed circuit board for the DragonFly Cobalt. So once both passes are made through the surface mount line, the board is taken to the Aoi Inspection System, which stands for Automated Optical Inspection. This is an insane machine that looks at a variety of defects that can be caused on the circuit board. It can look at the values of the components, insufficient solders, anywhere where we have shorts or malfunctions in the placement process. If any defects are found in the AOI system, then they can be delivered over to the rework site where any necessary repairs can be made.
We are now at the specific stage of the process to program the integrated circuits on each unit. At this stage, it may be tedious, but it's very critical that it's done correctly. What we are doing is programming the brain to tell it what it is, and now it becomes a Cobalt. It's now time to take a large panel and cut them into individual Cobalt units. Now that the boards are depaneled individually, it's time to test them, listen for the specific audible frequencies and that they are working properly.
And now that the Cobalt are tested, we're going to put them in their protective shell. I like to see the board itself, and then once you get that board inside of the shell and glue it, it's like you lay it down there and this is something that you have made. Wow. And people can use it. Once the Cobalts are glued into their shell, they will be setting for 10 minutes, and then we were able to use them to package them. There's a lot of critical steps in order to package the Cobalt. Everything's in there, put your hooks down. And that's all we do to them. You just take it, hold it, go right there, and then we set it up. And this is how we make AudioQuest DragonFly Cobalts here at Mirac, Lynchburg, Ohio.
We make all of the DragonFly products in the USA because it works better for us. We have the ability to keep quality control really high. Mirac's been a great partner over the years. We can, do custom test equipment. We chose them over, working in the Far East because I can go there anytime that we're needed. I can just hop in a car and, in 40 minutes be there and work out any problems. They've been a great partner for a long time. Thank you very much for watching.
We have these 3 Cobalts to give to Darko.Audio YouTube subscribers. Simply leave a comment below telling us what device you would use the Cobalt with and why, in 50 words or less. We'll pick 3 winners a month after this video goes live. And that's all from us here at Mirac in Lynchburg, Ohio. We hope this video gives you some insight into how portable DACs are made right here in the USA. Thanks for watching.
She doesn't know that I really like doing this.
I have trouble trying to dumb stuff down, but we'll see. But then all my engineering buddies are gonna laugh at me when they see this, because they're like, does this guy even know what he's talking about?